All right, folks, so we're going to be finishing up with Chapter 2 here. We're not doing all of the sections. This is going to be our last official section from Chapter 2 that we're going to cover. We do have a couple other things that we are going to look at that I'm kind of dumping into Chapter 2 here. This right here is called literal equations and formulas. Make sure you get these vocab words copied down. A literal equation is just an equation that contains two or more variables, and we'll look at some examples of that in a second. Formula is a special kind of literal equation that states a relationship among quantities. So those are formulas that we use for a lot of different things. For instance, a velocity has a formula, or distance equals rate times time. That's a formula. That's what we're talking about when we're looking at formulas. So you may not have been aware, but the NFL has recently started, and this is a great picture that just the timing was perfect on that. Oh, man. I don't know what that guy ate. I'm guessing some Whiteys. Okay, rewriting a literal equation. The equation 10x plus 5y equals 80, where number of pizzas, y is the number of, x is the number of pizzas, y is the number of sandwiches that you could buy, and 80 is the amount of money you have. How many sandwiches can you buy if you buy 3 pizzas, 6 pizzas? So I know that you could go ahead and just start substituting in these values here for this. But the question is, how many sandwiches can you buy if you buy 3 pizzas, if you buy 6 pizzas? So in other words, I'm looking for this, the number of sandwiches for 3 and for 6. I might continue going, 10 pizzas, 20 pizzas, 100 pizzas, and so on. In other words, I'm wanting this to be an output. So when I look at this equation, I could isolate that y and go ahead and what's called solve for y. And that makes this problem easier to work with. And let me go through it and then I'll explain what I mean. So here I'm solving for this variable. Whenever I solve literal equations, I like to just put a little arrow over the variable I'm trying to isolate. It just helps me remember. So I'm trying to get this y by itself. So the first thing here is I'm going to subtract 10x from both sides. Now be careful on this because here, these can subtract, but over here, I cannot subtract x from this because they're not like terms. So I'm going to write it like this with my variable first. Negative 10x plus 80. If you wrote it the other way, 80 minus 10x, that would not be incorrect. Again, this is just a preference thing. Here I have 5 times y, so I need to think, well, how do I undo multiplying by 5? I could divide by 5, or because I'm coming over here and I'm going to be doing some multiplication, my preference is to multiply by 1/5. And this has to do with that whole thing that we looked at a couple sections ago, where if I realize that 5 is the same thing as 5 over 1, and I have to divide by the fraction 5 over 1, that's the same thing as multiplying by its reciprocal. And what happens here is that these two 5s simplify and I'm left with y. If I multiply this side by 1/5, then I also have to multiply this side by 1/5. And I draw my rainbow. So here I'm left with y equals negative 2x plus 16. Now I have the y isolated, and it's fairly easy from this point to go ahead and just plug in a 3 right here. In fact, this becomes a mental math. I'll still write it out, but I could do negative 2 times 3 plus 16. So that would be a negative 6 plus 10. So for that, I could get 4 sandwiches. Or if I get 6 pizzas, I'd have y equals negative 2 times 6 plus 16. So that's a negative 12 plus, whoops, this shouldn't be 4. People got to catch these mistakes. That's 10 sandwiches. I was getting ahead of myself. Negative 2 times 6 is 12. Negative 12 plus 16 is 4. I should write out the steps, but I'm running out of room. So let me double check that. Yeah, 10. Okay, so the reason that's helpful is if I'm putting in multiple values of pizza, different values for the x, it's easier to go through the problem and evaluate with different values like this than it would be to go here and say, okay, I'm going to put in 6 for x, and then we'll go that direction. Now, this just makes it a simpler process to go ahead and solve for this y in the first place. So that's kind of the gist of what we're doing today. Rewriting a literal equation with only variables. So notice here that there are no coefficients other than the assumed coefficients of 1 or negative 1. So it says solve ax minus bx equals c for x. Now I want you to notice here that there's an x here and there's an x here in both of these terms. And this is where you have to think a little bit. So we know that when something has this x kind of distributed through it, that means that the distributive property could have potentially been used to get that x there. So what we're going to be looking at on this one is to undo the distributive property. So in other words, this is called factoring. I want to factor out an x. All right, so I'm going to write the x in front. And what I'm doing here is, in essence, I'm dividing everything by this common factor. So ax divided by x leaves me with a, and bx divided by x leaves me with b. Now think about what happened here. Okay, if I wanted to go backwards, if I wanted to reverse what I just did here, come on now. If I wanted to reverse what I just did, then what I would be doing would be using the distributive property, right? So I would come up here and I would have a rainbow here, and then I'd have a rainbow here, and I have a times x, which is ax, and then here I'd have the b times x, which is bx, and then I need to write out the c. So what I did here was undo the distributive property, and undoing that again is called factoring. So here, now I have a value. I want to get this x by itself, so the way I do this is I divide both sides by this a minus b. And this is one that you'll want to make sure you take good notes on. Students have a tough time with this, and I want to make sure that we're successful. So here, because it's in parentheses, I could treat this entire thing as its own term, which means that these two things can simplify out, and I'm left with x. And then over here, I'm left with the c in the numerator, and then a minus b in the denominator. So right there is my solution. All right, so take a moment and try to process through that. I know that's kind of tough, and if you have questions in class, make sure you ask, but that is what we're looking at in this particular section. All right, so you go ahead and give that one a try. You're solving for x on this one. You don't have distributive property in this one, so hopefully it's a little bit easier for you. All right, so here are the answers on this one. Hopefully you got that, and if not, go back and try to find where your mistake might have been. So let's keep moving here, maybe. All right, so here's some well-known formulas. You don't necessarily need to write these down. You are given formula sheets for most of this stuff when you have quizzes or tests, and at the end of the year when we take our final, you have most of these formulas written out for you, but you should know a lot of them, or at least be familiar with them. So take a moment. I'd pause and just read through those and make sure that that's something that you are familiar with, and may want to copy them down. I don't know. That's up to you. So here, rewriting geometric formula. It says solve the formula for a circumference of a circle for the radius. So the circumference of a circle formula on that other sheet was c equals 2 pi r. And on this one, I'm wanting to solve for the radius. So this is a pretty simple one. The way I get that radius by itself is I divide both sides by 2 pi. So here the 2 pi simplify, and I'm left with c over 2 pi. I'm going to rewrite it in this order. The radius equals c over 2 pi. That is the formula for a radius. All right, so that one's pretty quick, right? A lot of these geometric formulas are pretty easy to rewrite when solving. Some of the ones that get a little more difficult would be, using the trapezoid. That's a ugly formula. What is the radius of a circle with the circumference of 64? Use 3.14 for pi. Okay, so we're going to take 64 and substitute that in for c. And then I have 2 times, and instead of pi, I'm going to use 3.14. I know your calculators have a pi key. I don't really care if you use it. That's perfectly fine with me. So let's go ahead and continue working. So I have r, radius equals 64 over 6.28, which is incidentally a number called tau that you don't hear a lot about, but it is an actual number. And when you punch this into your calculator, feel free to use your calculator on this, you get R equals, let me double check here, 64, yep, 10 and 1900ths if we round. All right, so we'll say that that's a rounded answer, and that's good enough rounded 2 decimal places. All right, so let's take a look at another one here. Oh, never mind, that's the end of the show. So I will see you guys in class. This one might have questions with it, so make sure that you are bringing those questions with you if you did not understand something in this particular video.